The explanation of the universe's origins has always been a topic of discussion. Many scientists have supported the idea of the Big Bang theory, which suggests how the universe began. However, with new discoveries in science, fresh perspectives and ideas are emerging. These new studies challenge our previous views, especially when looking at the work of prominent figures like Neil deGrasse Tyson. Recently, something interesting has been discovered with the James Webb Space Telescope. It's important to note something that might make us rethink the theory of how the universe began. The James Webb Space Telescope has found 750 new galaxies. These galaxies don't look exactly as expected, leading us to question what we thought we knew about them. This discovery will help us understand how large galaxies grew, and it's no surprise that it's making us reconsider how we might unravel the universe's past. Scientists once believed the Big Bang theory explained the universe's beginning. According to this theory, the universe began about 13.8 billion years ago through a mysterious event similar to the dramatic story of the universe's birth. But the images from the James Webb Space Telescope challenge this idea. They show galaxies that are more complex, smoother, and older than we expected, which doesn't match what the Big Bang theory predicts. According to the theory, as the universe expands, objects should appear clearer the farther away they are. However, these new findings from the telescope do not follow this pattern. The Big Bang theory also states that at the beginning all the matter in the universe was squeezed into a tiny superdense point called a singularity. This singularity was incredibly hot, hotter than anything we can measure today. This idea comes from the general theory of relativity proposed by Albert Einstein. In this singularity, all the universe's mass and energy were packed into a small space, which is a lot of matter and energy for such a small area. In simpler terms, scientists have always said the Big Bang theory is the explanation for how the universe began. However, the new pictures from the James Webb Space Telescope are forcing us to question that the galaxies it found don't match the expectations of the theory, and it suggests the explanation of the early universe might not be as strong as once thought. In our current view of the universe, we believe all the energy came from a hot and dense point called a singularity. After this point, the universe began to expand and evolve over about 13.7 billion years to become what we see today. This expansion started with something called the Great Expansion, where the universe grew incredibly fast, much faster than the speed of light. Perhaps the very surface of space itself was expanding, and everything in it expanded along with it. This rapid growth helped shape the universe by making things more even, allowing galaxies, stars, and other structures to form. As the universe continued to grow, it didn't expand as quickly as during the Great Expansion, but it still kept expanding. This ongoing growth is called cosmic evolution. Scientists have noticed evidence of this growth, like the way light from distant galaxies changes in color, known as red shift. Now, let's take a closer look at the amazing pictures of new galaxies taken by the James Webb Space Telescope. To most people, these photos are breathtaking, with many galaxies captured in one frame, but for scientists, it's surprising that these photos don't match what their theories expected. For one, these galaxies are older than expected, which challenges our understanding of how galaxies form and evolve. According to the Big Bang theory, there should be fewer galaxies in the early universe, and their arrangement should follow certain patterns, but the James Webb images show many more galaxies than anticipated, which leads scientists to question whether the theory's predictions are accurate. Some scientists are starting to think their ideas, because these discoveries don't align with their current understanding. Another surprising feature of the new images is the perfect appearance of these galaxies, which contradicts what the Big Bang theory suggests. According to the theory, galaxies should have irregular shapes and designs due to the way they formed and grew, but the photos from the telescope show galaxies that are smooth, without the usual chaos and complexity that should have occurred during the universe's early stages. In the first few minutes after the Big Bang, processes like nucleosynthesis took place, creating elements like hydrogen and helium. These elements paved the way for stars, galaxies, and other complex structures to form. As the universe continued to evolve, the Big Bang theory predicted we would see galaxies that were chaotic and irregular, but the James Webb images tell a different story. Instead of chaotic galaxies, the photos show smooth, round, and spiral shapes, similar to what we see in galaxies today. This discovery raises questions about the role of chaos in the evolution of the universe. If these early galaxies are so calm and orderly, it seems unlikely that small galaxies could have grown into large ones. Similarly, the expected optical effect from the expanding universe, where objects should appear smaller the farther away they are, doesn't seem to be present in the new images. Scientists have noticed a pattern where massive structures tend to group together in large clusters, forming different organizations across the universe. This large-scale structure fits with the predictions made by the Big Bang theory. According to the theory, the universe began as a very hot and dense state, and as it expanded and cooled, gravity played a key role in shaping how matter was distributed and in organizing galaxies. The gravitational effects predicted by the Big Bang theory match what we see today, where gravity causes matter to clump together, leading to the formation of galaxies and the creation of a vast interconnected structure known as the cosmic web. The existence of these galaxy clusters and the cosmic web strongly supports the Big Bang theory. How galaxies are spread across the universe matches the gravitational effects predicted by the theory. The evidence of galaxy clusters, the cosmic web structure, and the spread of galaxy groups suggest the universe expanded from a very dense state and has been growing for billions of years now. Let's look again at the size of the galaxies seen by the James Webb Space Telescope. These photos go against what we thought we knew about the Big Bang theory. According to the theory, small galaxies should form and grow through collisions and mergers with other galaxies. However, the galaxies captured by the telescope don't fit this idea. If cosmic structures were colliding and merging as expected, we would see signs of these crashes or mergers, but the photos show something different. Despite these surprising discoveries, the Big Bang theory is still a powerful idea. It is supported by solid evidence such as the red shift of light and observations from distant galaxies. Studies showing galaxies moving away from each other suggest a steady expansion as predicted by the theory. The distribution of light elements like hydrogen and helium throughout the universe is also consistent with the Big Bang theory. Furthermore, the large-scale distribution of galaxies, as shown in galactic maps, matches the patterns the theory predicted. One of the key pieces of evidence for the Big Bang theory is the discovery of the cosmic microwave background CMB. The CMB is faint radiation that fills the entire universe and is considered the leftover glow of the Big Bang. This radiation was first detected in 1965 and still aligns with the predictions of the Big Bang theory. The characteristics of the CMB, its consistency and temperature distribution, strongly support the idea that the universe was once in an extremely hot and dense state before expanding. The discovery of the cosmic microwave background provides a rare glimpse into the universe's early moments. It acts as a remnant of the first stages after the Big Bang, helping us confirm the size and development of the universe from its beginning. The discovery of the cosmic Microwave background CMB is a crucial piece of evidence that supports the Big Bang Theory. It provides us with valuable information about the early universe, acting as a snapshot of the universe. Just a few 200,000 years after the Big Bang, the CMB's temperature and uniformity across the universe are consistent with what the Big Bang Theory predicted about the early conditions of the cosmos. Even though the James Webb Space Telescope has raised questions and brought new findings that challenge certain aspects of the Big Bang Theory, the theory still stands strong with overwhelming evidence. The CMB remains one of the strongest pieces of proof that supports the idea that the universe began from a hot and dense state and then expanded over billions of years to become what it is today. In addition to the CMB, the ongoing observation of distant galaxies, the red shift of light, and the cosmic web structure all lend strong support to the Big Bang Theory. These observations align with the predictions made by the theory, showing that galaxies are continuing to move away from each other, indicating the universe is still expanding. The James Webb Space Telescope's images have brought some unexpected results, but they also show us how much more we still need to understand about the universe's origins. The discovery of ancient, smooth, and unexpectedly large galaxies challenges some of the assumptions about how galaxies form and evolve, but instead of invalidating the Big Bang Theory, these findings push scientists to refine and expand our understanding of the universe's history. As we continue to learn more about the universe, the Big Bang Theory remains a powerful framework supported by substantial evidence. However, the mysteries revealed by the James Webb Space Telescope remind us that science is always evolving. The more we discover, the more we can refine our IIEs and deepen our understanding of how the universe came to be. The new insights from the James Webb Space Telescope challenge our ideas, but they also open the door to new questions and possibilities. As scientists continue to study these findings, we can expect our understanding of the universe's beginnings to grow even further. While the Big Bang Theory may still be the best explanation for the origin of the universe, the new discoveries remind us that there's always more to learn, and science continues to evolve as we explore the cosmos through the efforts of researchers and the incredible tools at our disposal like the James Webb Space Telescope. We are constantly learning more about the vast universe around us, piecing together the story of its origins and uncovering new mysteries that could shape our understanding for generations to come. As we move forward in exploring the universe, the discoveries made by the James Webb Space Telescope offer exciting new perspectives on how galaxies form and evolve. These groundbreaking images have shown galaxies that appear different from what we once believed, raising many questions that challenge traditional theories. Despite these challenges, the quest for answers is not about dismissing old ideas, but rather expanding and refining them. Scientific progress often involves reassessing previous models in light of new evidence. One key takeaway from these discoveries is the importance of maintaining an open mind. While the Big Bang Theory remains one of the most widely accepted explanations for the universe's beginnings, the new data forces us to think deeper and consider other possibilities or nuances within the theory. It's a reminder that science is always a work in progress. Each new discovery builds upon what came before, helping us inch closer to understanding the true nature of the cosmos. For example, the James Webb Space Telescope's ability to look farther into space than ever before has allowed us to see galaxies in their earliest stages. These findings could provide clues about how galaxies, stars, and other cosmic structures formed in the early universe. Scientists are now working to understand why these galaxies appear to be more mature than expected, which could lead to new models of galaxy formation. In addition to galaxy formation, the telescope is providing detailed images of distant stars, nebulae, and other objects that can give us more insight into the processes that shape the universe. By studying these distant objects, we can learn more about the physical laws that govern space and time, and refine our understanding of gravity, dark matter, and dark energy. Furthermore, the telescope's observations of the cosmic microwave background (CMB) continue to provide valuable data. As researchers analyze the CMB, they can learn more about the universe's early conditions, including its temperature, density, and expansion rate. This data will continue to play a crucial role in confirming or challenging our current theories of the universe's origins. As the James Webb Space Telescope and other advanced tools continue to expand our knowledge, we can expect even more exciting discoveries in the years ahead. These discoveries might not only lead us to a deeper understanding of the Big Bang Theory, but could also challenge us to rethink fundamental aspects of physics, cosmology, and the universe itself. The more we explore, the more we realize that the universe is filled with mysteries waiting to be solved, whether it's the formation of galaxies, the nature of dark matter, or the forces that shape the earliest moments of the cosmos. There's still much we don't know. The journey to uncover the universe's secrets is far from over, and each new discovery brings us one step closer to answering some of the most profound questions in science. In the end, the story of the universe's origins is one that will continue to evolve as we gather more evidence and refine our theories with tools like the James Webb Space Telescope, pushing the boundaries of what we can observe. We are entering an exciting new era of discovery that will reshape our understanding of the cosmos for generations to come. As we look to the future, we must embrace the unknown, knowing that every breakthrough brings us closer to understanding our place in this vast, incredible universe.